All right, so lesson 2, review, go. Okay, so lesson 2 is about polynomials and their graphs, right? First things first, like everyone, this will be on your quiz. You've got to be able to graph this using an XY table. Plug in the X's, find your Y's, it gives you points. Boom, 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 boom. Now, how do you know what else to fill in? That's about end behavior, okay? And end behavior was its own lesson. It's lesson 3, it's the next lesson. I'll touch on it here. I'll emphasize it there, right? But if you know the points, you know where it begins, you know where it ends, that's basically all you need to graph this good enough for the quiz, okay? You want to know the degree. You want to know if it's reflected. We're going to talk about that, okay? Now, another important thing to note is if you know the factors, right? Boom, 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 you know the roots. X plus 1, x minus 2, x minus 2. Well, that means my roots are -1, 2, and 2 again, right? Double root. One thing to take note of here, when you have a single root, it crosses. Look what happens when you have a double root. It doesn't cross. It almost looks like it bounces off the x-axis, right? That's going to hold true, okay? If you have a triple root, I'll talk about that another time, right? We won't be quizzed on that yet, but this is coming, so it's good to know. One root will cross, 2 roots bounce. So double roots bounce, okay? Some things to notice about a graph. Like, okay, when we had parabolas, right? It was like this, and it had a minimum, never went below it. Or it was like this, and it had a maximum, never went above it. Now, those were called vertexes, right? We can't use the word vertex here, because it's not a vertex. But we do want to talk about maxes and mins. But we use this, like if we're looking at this right here, right? It's the max of this little area, right? It's definitely the max here, but it's not the max of the function, because the function actually ends up going all the way up there. So what we say is we call it a local max. It's the max of that area, that local area. And this is a local min. It's the max of that, it's the min of that little area, right? So local min and a local max. And the other thing you want to start recognizing is how a function behaves. It's increasing, it's decreasing, it's increasing, right? When you go from increasing to decreasing, when you change from one to the other, or decreasing to increasing, that's where you have a local max or a min, right? Because that's when you get these points where it changes direction. So things to recognize in a graph, okay? All right, this is end behavior. I'll talk about that more in that lesson. But we'll talk about it with words, right, like pretty soon here. Okay, so even versus odd. We talked about this a little bit already. Even functions, right? Even functions have a degree that's even. To the second, to the fourth, to the sixth, to the second, all even numbers. If you know a function is even, you know something about it. You know it either goes like top, top, or bottom, bottom, right? So if you know it's this or this, it doesn't matter if it's x squared, doesn't matter if it's x to the 6th, to the 8th, whatever. If it's even, it's top, top, bottom, bottom in terms of its end behavior, in terms of where it begins and where it ends, right? Now the other thing you want to look for is it reflected, right? If you have a parabola that's not reflected, it's top, top. If there's a negative out front of that parabola, it's bottom, bottom, right? Here's a reflected parabola, bottom, bottom. Here's a not reflected parabola, top, top, right? The same thing will be true for any even function. Think back to a parabola every time if you need to. This one is to the 6th. Do I know what something to the 6th looks like? Maybe, maybe not. But I do know it's even, so it's either this or this. And I know it's negative, so it must be this. So I know it starts at the bottom, ends at the bottom. So you know the degree, you know if it's reflected, you know those things. This one is to the 4th. So I know it's either this or this. It's not reflected. There's no negative out front. So it's just like a regular parabola, top to top. Does that make sense? That's even. Now, remember when I said thinking about even functions, you kind of want to just picture that parabola because you know it's going to be like a parabola. For odd functions, picture a line, right? A line is an odd function. X to the 1 is an odd number, right? So it's an odd function. So any odd function will behave kind of like a line. Think about a line. A positive line starts at the bottom, ends at the top. A negative line starts at the top, ends at the bottom. That's true for any odd function. Question?
Is it always going to be left to right?
Yes, you think about it left to right. Think about it left to right. And then when we get into end behavior, that adjusts a little bit. But if I'm thinking about it in terms of words, starts and ends, it's starts at the top, ends at the bottom. Now, think about, use that line knowledge to look at these other functions. This is x to the fifth. We know it's odd, so we know it's bottom to top, top to bottom. It's one of those two. It's not reflected. So is it going to be like a positive line or a negative line? If there's no negative out there, so it's going to behave just like a positive line. Well, what do positive lines do? They start at the bottom and they end at the top. What does this positive odd function do? It starts at the bottom, ends at the top. This odd function, it's x to the third, so it's odd, and it's negative, so it's reflected. Just like a negative line starts at the top, ends at the bottom, this negative odd function starts at the top, ends at the bottom. Right? So if you remember odd, find the degree, see if it's reflected. If you can answer those two questions, and then you picture that parabola, picture that line, then you'll know. Now, the thing that will happen, the skill that you need on a test, will be something like this. I won't give you a graph. I'll just say, hey, look at this function. Tell me its end behavior. And we'll talk about notation in a second, but talk about it. Talk about it. And you might be like, well, how do I know? Well, let's answer those questions. Is it even or odd? Odd. Is it reflected? No. So it's going to behave just like a positive line. How do positive lines go? They go like that, right? So it starts at the bottom, ends at the top. This function, in fact, would look like this. And when I give you this question on the quiz, I'm not going to say, hey, draw a little sketch to help yourself. But you probably should. It makes it really easy, right? Once I draw the sketch, now I can answer this question pretty easily. Starts at the bottom, ends at the top, right? This one, I forget what x to the fourth looks like, but I do know it's an even or odd function. X to the fourth?
We're looking at
it's the highest degree, hottest power that you see. Even. So that's either going to be this or this. And it's negative, so it's going to be down. So it starts at the bottom, ends at the bottom. Right? Starts and ends at the bottom. And if you wanted to draw a picture, it would look like that. You don't have to get the picture right. I'm not grading the picture. Maybe you put an extra bump in there by accident or something. Right? I don't care. It still tells you the end behavior story that you need to answer the question. Okay? So draw yourself a picture with the knowledge that you have. It'll help you. Okay? Questions before we move on to the notation for this stuff? Okay. So, we can't be writing starts at the top, ends at the bottom, or left, when it goes left, it goes this way, when it goes right. We use notation in math. We use ways to write that a lot quicker. So that's what the next lesson's about, is that notation. Okay? So go ahead. If there are no more questions, go to that next lesson.